great workshop, and maybe I have a chance eventually to join this kind of discussion in the future. I wish you good luck and stay healthy. Thank you.
Thank you. Okay, so yeah.
All data sets are shit. There are problems with every data set.
Yeah, and those, I mean, the point exactly is that there is this tension in the middle.
Yeah.
And there are several walls that are pulling.
Yeah.
And we should be conscious about our space, where we are relative to other people, and resolving those tensions might help us answer the questions better. Because we do stay in some particular places for a long time. And then when it has to move to a center space or mediating space, it's not always easy because we are specialists in different things. So big data, all that, the point was that there's a middle space that we could engage better, create new language for Envision, yeah, so that was the point. So we have a coffee break for 10 minutes.
Make it 15 if you want. I don't need the full time. So.
Okay, so we can make it 15 minutes. I have the person presenting next, Daniel, has given me 5 minutes extra.
Well, we had a short lunch. So
yeah. So just grab your coffee. Don't drink too much, and come back refreshed again. It's going to be like hands-on and very, very also interesting. So just come back in 10 to 4. Yeah.
Sorry, 10 to 3.
10 to 3. Sorry.
Yeah.
Great. Yeah, so thanks very much to the organisers for inviting me. I think this is a really interesting project. It's a great data set, and there's some clear opportunities to extend my work by looking at this data as well. So I'm going to talk about MultisSyncPY, which is a Python package, so some software that you can use to add to the toolbox. I've seen that the toolbox is already quite crowded, and there's quite a few things that are really exciting, and some of them I hadn't encountered before. So I think there's some really interesting tools, and hopefully this is a useful addition. So this is some work that I did with my collaborators, Travis Wiltshire from Tilburg and Martin Atzmuller from Osnabrück. Actually these times are probably a bit wrong now. I'll stretch it out slightly. But yeah, I'm going to talk a bit about what multivariate synchronization is, or synchrony is. Then have a look at which methods we provide in MultisSyncPY to quantify it. And then there'll be a bit of a demo as well, so I'll kind of show you what the code looks like, and I think it's fairly simple to use, so hopefully something that people can start taking up and using, even if they aren't very experienced with programming. Then obviously it'd be good to have a bit of a discussion and get some feedback and thoughts from people. I didn't realise that synchronization would come up already in the workshop, but I get the impression that it's been mentioned quite a few times, or coordination in some sense. So I thought this might be kind of a fringe topic, but actually it seems quite central to what a lot of people have been thinking about. So that's already good, gives me a good starting point here. So yeah, synchronization is something that is demonstrated in all sorts of systems, especially what we would call complex systems. And I've got some examples here, like fireflies, pacemaker cells in the heart, stocks and shares and financial indicators. Plants as well, brain waves and different regions of the brain can synchronize. There's an animation here, which I'm not sure you can see that clearly, but those are some fireflies from Thailand. It's a specific type of firefly that synchronizes in its flashing, whereas I think the American firefly doesn't. So in Thailand, they synchronize.
They're very individualistic.
Yeah, that's it. Maybe, I don't know, there's some sort of political metaphor to be had there, yeah. And synchronization is related to some other terms. So kind of a temporal alignment is maybe one of the easiest ways to think about it. But coordination also, I mean, you can maybe even think of things being coordinated across space as well as across time. And most of the traditional approaches to measuring synchronization and to quantifying it are bivariate. So they're looking at two different signals, or maybe you'd be looking at two people and how they synchronize. But I think that has some limitations. I mean, if you look at these fireflies, there's definitely more than two of them. So yeah, even already with the Envision data set, you have more than two people, and you might want to analyze how a group is synchronizing or not. And that's what we try and resolve or try and address with this package. And obviously the relevance here is that it's something you can use to study physiological signals or teamwork. Maybe it's a bit redundant to say this given the audience, but yeah, I mean, obviously there's reasons to believe that for a team to be effective, they need to coordinate. So if you can measure synchronization, you can see one aspect of this coordination, and quantifying it like this, you can also look at how it changes over time to understand the dynamics, and you can do more if you're able to quantify it. Yeah, so I suppose you're probably aware of this, but it's useful for teamwork.
Can I ask you a little question about coordination?
Mm-hmm.
It seems that synchronicity and coordination may not be, depending on how narrow I mean, the real question is, what is synchronicity? If we're talking about coordination, everything isn't happening at the same time. But we would say there is a type of synchronicity in that people are doing their jobs, right?
Yeah.
Or how big is the time frame for synchronicity? Is it always immediate, like the fireflies, or is it, well, these people are doing these things within a 5-second phrase, so to speak?
Yeah, that's something that I'll come on to a bit later, maybe at the end. Actually, it's a kind of an open question that about, I guess, the lag between one member in a group and another behaving in a certain way. At the moment, we've been focusing on kind of in phase or simultaneous synchrony, because I think that's easier to understand with a large group. Otherwise, it gets very hard to follow. If there's 100 people, who's ahead of whom, and is this person really matching with that person? But it's a good thing to bear in mind. Yeah, it's maybe an open question that we can discuss at the end. Is how would you account for the fact that there might be lags between people, and also, yeah, people maybe have different functional roles within a team. That means that we're doing different activities, but there's still some coordination with it.
Right.
Although I would say you can probably still detect that with these kinds of methods.
Okay.
Yeah.
Cool.
Yep. So the package that we've created, MultisSyncPY, available in Python, gives you 6 different methods for quantifying how synchronized a group is. And I'm not going to read them out yet, but hopefully by the end of the talk, you'll have heard these names a few times, and maybe some of them will start to stick. And now I'm just going to give a kind of an overview of these different metrics and how they're computed. So the first one is multi-dimensional recurrence quantification and analysis, which people call MDRQA for obvious reasons. And this is sort of answering, or it's based on the question of which points are similar to which other ones. So I've created some kind of 2-dimensional measurements here as time steps, these kind of vectors of two measurements. So there could be 2 people or whatever. I chose 2 just because you can visualize it really. You can see with the kind of the flashing animation in the corner, with these 2 variables, you can kind of visualize where these points are in a Euclidean space and see how close they are to each other. So you can see, I think it's T1 and T3 are very close to each other, right? They don't vary that much in these values, but T2 is kind of way out somewhere else, so it's quite distant. This information you can capture in a recurrence matrix. And yeah, so you kind of go to a distance matrix, and then recurrence matrix is kind of the same thing, but just with some threshold applied. And if they're close enough, you say they're recurrent, and if they're not close enough, then you say they're not recurrent.
Can you tell me what I'm supposed to be seeing in the distance matrix that makes sense to me in terms of the points, the 4 points?
Right. Well, this is more than 4 because I thought it'd be good to show a larger
Okay.
distance matrix, but they would be kind of 4 rows and 4 columns of it.
Okay.
So each row is one time point and each column is another time point. And you can see that there's this diagonal of zeros or no distance because that's kind of comparing point 1 to point 1, point 2 to point 2. As you go further into the corner, you have the first point, the top right corner, for example, you're comparing the first time step to the last time step in the sequence. And the various metrics that people use on these recurrence matrices based on the diagonals. So this is actually going back to the question of lag, actually. So it's comparing the system at one point to the system at a later point. Another thing that maybe is important to think about, just to get into the right frame of mind here, is that we're kind of looking at the system as a whole, and we're looking at a kind of an idea of system states, which you can think of as, you know, what's the system doing right now? The measures that, or the variables that we're using and we're measuring in the system, what are those values right now? That's kind of the state of your system, and we're comparing the system from one point in time to another point in time. Determinism is the one that I think is probably most commonly used or people find most important, and that's measuring these kind of sequences along the diagonals where the system kind of repeats or it resembles itself at an earlier time, and it continues kind of doing that for several steps. So moments 1, 2, 3 are like moments 9, 10, 11, for example. That would be, if that occurs, then it's going to increase your determinism. And the last thing to note is that there's a parameter here, which is the radius. So that's supposed to be the kind of flashing red circles. And yeah, that's just kind of thresholding the distance matrix to turn it into a binary recurrence matrix. And I think, yeah, the idea here is just that if the system is returning to states it's already been in before, and if it's doing that with a kind of a pattern, then you can see it from this technique, and that is a sense of, in a sense, some synchronization or coordination, that there's a repetition at the system level rather than the individual level. So the next metric we have is symbolic entropy. Entropy is used to measure how chaotic a system is. And the first step in this is to, in some way, kind of discretize your values. So here we use tertile boundaries. So you can see if things get into the kind of top third of values, they're green in this illustration. If they're in the middle value, they're red, and low values are blue. Then we kind of combine the different signals. So in the top right-hand corner, we kind of have 3 different signals, which could be 3 different people in a group meeting, or 3 different people in an Envision meeting. And then you're going to condense 3 different people to be one symbol. So it could be kind of red, 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 or it could be green, 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 red, etc. Representing, yeah, that everybody's in a low state of movement or everybody's in a high state of movement. One person is, 2 people aren't, etc. And then these symbols, you can look at the distribution of them, and from that you compute your entropy. So again, the symbols are measuring the system as a whole rather than the individuals, and it's about seeing how ordered the system is or how disordered the system is. And the idea being that if the entropy is lower, the system is more ordered, and then you have some sense of synchronization or coordination. Next one is going to be coherence. So I won't go through the full calculation. Oh yeah, of course, yeah.
So that's just Shannon entropy, or is it like also if you shuffle it, at least is it time dependent, like simple entropy, or?
No, this is yeah, this is really just looking at how often they occur. So it's kind of a histogram based Shannon entropy. Like you put the values into bins and then you do your entropy. Yeah. Yeah. So coherence is based on frequency components. So I guess people are familiar with things like spectrograms or whatever, or the idea that each or any signal can be represented by an addition of different sine waves. So there's kind of any signal you want to analyze has different amounts of power at different frequencies. There might be a lot of low frequency power, or it might be high frequency and so on. And anyway, the combination of what's happening at different frequencies that will actually add up to the original signal in some sense. Coherence is based on this, so it's a kind of frequency-based analysis. And the interpretation is that it indicates how well one signal can be approximated by a linear function of another. Slightly different from the previous two measures, which weren't assuming linearity. So that's maybe one thing to bear in mind. And also, based on our experiments, we found some things that we weren't that keen about with coherence. So we just created our own metric, which is very similar, but just normalizes things differently, which we thought helped to reduce the impact of noise in certain ways. Maybe I'll come back to that later. But these are very similar anyway. I mean, they're basically the same, it's just normalized differently. And we're also averaging across components. So this is slightly different from, we're averaging across frequency components, we're also averaging across dyads. So it is slightly different there, that it's not directly measuring the system, it's measuring the dyads and then averaging. Okay, so there's two more left. Cluster phase rho is based on the idea of phase. So many signals have some periodic quality to them. There's a pattern and the pattern repeats. And the phase time series is something that you can extract from a signal that tells you how far you have progressed through your pattern, through your repeating pattern. Once you have this for all the different variables, you do this individually for each variable, for each person in the meeting. Then you can compare the different phases at each time point, or across all the time points. You can kind of aggregate them and see whether there's a kind of a phase relationship, that I'm progressing at the same speed you're progressing, or one person is progressing faster than the other, whether they're in phase or out of phase with one another. And you can use this to obtain a synchrony score, or a quantity that's just an overall summary of a meeting. Although you can also use it to get a summary at each time step if you want to. The last metric that is included in the package is the test on the Kuramoto order parameter. So Kuramoto was a mathematician who came up with a model of how simple oscillators synchronize. So you could even think of something simple and mechanical, like some swinging pendulums. If you have 4 of them and they have even just a small way to interact with one another, then eventually they align and they synchronize. And this happens even if you set them off at completely different starting points and different speeds and stuff. They can anyway in certain conditions synchronize. So there's a mathematical model that this is based on. Also based on the phase, like the previous metric. So both of these are based on phase. And this thing that's called the Kuramoto order parameter is really just a way to summarize the phase across all the variables. There's one last thing that makes this slightly different from the previous metrics, in that this is looking at not just one recording, but multiple ones. So it wouldn't just be looking at a single meeting from Envision, it would be looking at all of the meetings from Envision. And basically it tells you whether the synchronization you see in your group of meetings is higher than what you'd expect from chance. So it's just asking, is there any synchronization at all going on? It's not really so subtle as saying, why is there synchronization, or what does it help with? This is just saying, is there some more than what you'd expect from chance? Because things can kind of look like they're synchronizing just because they, just due to chance.
I'm wondering if that's super interesting, right? Just, is that really synchronization? Or does that just happen that way? And I'm wondering if there are multiple cycles. That is, it doesn't just happen once at the end, but if it happens here, and then it happens here, and it happens here, and that would be, because we've been talking about when does chaos work, when does entropy work, not that one's a preferred state, but it's these cycles that may be what's really effective, because it's a cycle of breaking things apart and putting them back together, breaking them apart, putting them back together. So that's the.
Yeah, I think this is one of the reasons why it's really exciting to look at synchronization in the context of teamwork, because teams have different kind of tasks or micro processes, I've heard it called, right, where they have to do different things as a group, and the need to tune into one another or synchronize might be here at one moment, but then at a different moment, everybody has to go off and do their own thing for the good of the team. So yeah, definitely this can be, all of these things can be time varying, yeah, for sure. So here are all of the metrics on one slide. I'll just leave it on the screen for a second for people to glance through. Maybe I'll point out a few things. But obviously I don't expect people to remember all of this. You can look at the slides later for reference. Yeah, the first two are using this idea of system state and measuring how kind of ordered or structured the progression of the system is. The coherence and the sum normalized CSD have this more linear assumption. The last two are based on the phase, and depending on your data, you might find that the phase is a very sensible way to describe it. If people are behaving, maybe people have different tasks, but they have to align in terms of when the outputs are produced. So then you could find that the phase might be interesting. Each pattern's different, but people are progressing through their own individual pattern at the same time.
Or the converse of that, perhaps. That is, the output happens when they're in phase. Or it's perceived that this is an output.
Okay, yeah.
Right? Whether it's an output or not, it's perceived that, oh, well, here we have an output. Okay, here we have an output, and it just is a result, perhaps.
Okay, so that's an interesting question. Yeah, I think that would be a nice one to research in some way. I'm not sure off the top of my head exactly how you prove it one way or the other, but it's an interesting question. Yeah, how would you show that? Okay. All right, well, maybe we can come back to that with the discussion later, yeah. Are there any other questions at this point before I go on to the demos? Oh, yeah, please.
Yeah, just I'm not sure if it's a theoretical or kind of practical question, but I'm just kind of curious, is there like a minimum number of observations, for example, that makes these valid, or that you'd say you need to have a time series of X amount or X amount of variability or some other consideration for this, or is it pretty robust, these things?
I think it depends which one you're using, actually, yeah. I'm not as sure off the top of my head exactly what the minimums would be. I mean, I think it also depends how many variables you have and so on.
Yeah, fair enough, okay. Yeah, especially for me personally, I'm particularly interested in MDRQA and symbolic entropy, so I'm kind of thinking about those in terms of the chaoticness of the multivariate system or the recurrence or something like this, if you would have to have some kind of minimum for those.
I suppose my kind of dodging the question answer would be, you can always see these as kind of just summarizing what you have in the length that's available, kind of see them as a summary, and then your statistics could be based on comparing one condition to another or something like that. And you might still see systematically like the synchronization's higher in this group than that group, even if we only have short snippets per group.
Right. No, that makes sense. Thanks.
Yeah. Thanks.
Is Julia, does she?
Julia has a question. Yeah.
Oh, sorry. Yeah, can you unmute yourself and ask?
Yeah, sorry, jump into the question. Yeah, thank you. I mean, I've saw this package before, and I'm really looking forward to use it. If I can use this kind of metrics for E, because it's like 64 or like more channel for one system. And because I saw a lot of package like that, but more for movement, but not for EEG. So this is something that can be implemented, or?
Right, okay. I think, the connection broke out a bit, but I think I understood the question. It's about using this for EEG. Well, the coherence metric was actually taken from a paper that originally proposed using this for EEG. So the coherence was originally proposed for EEG. I'm pretty sure the other ones you can do too. Yeah, I don't see any reason why you wouldn't be able to.
No, because I haven't found any paper on that. So I was just curious if it's just because it's a nightmare or it's not appropriate, or, but okay. Good to know, thank you.
Yeah, I think that would be interesting, and I guess you'd be looking at within one individual. Would that be the idea, that you're comparing different regions, or see how multiple regions synchronize?
Yeah, I mean, it's for hyperscanning, so it might be also two. So yeah, potentially a lot of things to look at, probably.
Okay, maybe the only point I would make here is that for some of them, like MDRQA or symbolic entropy, you kind of want a system summary, and you're looking at how that progresses. Maybe if you've got a sampling rate that is that high, you might want to aggregate in some way and kind of come up with a you know, like, I don't know, take the energy or take the power at a certain frequency component per variable and just aggregate into a slightly more coarse-grained time series before you do this.
Okay.
Coherence, I think, works well because it's frequency-based anyway. And phase, I don't know if you want to aggregate or not. Maybe I'd leave you to figure that out. Yeah, I'm not sure on that one. I haven't tried it out.
Okay, yeah, I will think about that. Yeah, thanks.
Cool. Were there any other questions, or should I go to the demo now? I think I'll go to the demo then. Right, so I've got a few different packages that I'm importing just for the sake of kind of visualizing the data and so on. But MultisSyncPY here is the main one. It's quite easy to install as well. If you use pip, you just do pip install MultisSyncPY, and it will download itself and install itself on your computer, which is nice. So hopefully there's no issues installing it, but obviously just get in touch if you do. But I'm pretty sure it should be fine for everyone. There's some hand movement data that Vim sent over very kindly, so thanks for that. So this is hand movement from the Envision meetings. And I'll just load these and show some of them. So here it shows that there's sort of person one's left hand, right hand, and also the pen. So the pen is also being tracked in this data. Although in the end I didn't actually use that. It's cool, but I didn't use it in the end. Also, what I wanted to do was look at synchronization between individuals rather than synchronization between the two hands of an individual. So I just came up with a kind of a simple way to integrate the information about the left and right hand. And that's really just taking kind of the norm of this movement data. And these values are representing speeds of movement. So high value is where you're really waving your hand around, or a low value is where your hand's kind of steady. So this is not so important for MultisSyncPY, but it's just kind of aggregating the information so that each individual has a single number at each time step, rather than two numbers for two hands. The next part, I'm just going to take the first 1,000 steps, just to have something that I can plot a bit more easily. Here's what the data looks like, which is, as you can see, quite jagged, as a lot of movement data is. So in itself, that's kind of interesting. And this is the first meeting. Sorry, I forgot to mention that. But yeah, this is the first 1,000 steps of the first meeting in the Envision dataset.
Sorry, then. Do you know who is which color? Can you find it out?
I don't know, because I took this data rather than, I didn't have access to the videos, so I just have P1, P2, I don't know.
But you can identify P1 is green or something? Do you?
I could do, I can't remember exactly what the command is here.
Blue is probably one, right?
Yeah, I'm not sure. It's not the green. It's the.
I think there's green's probably two, yeah.
Oh, okay, okay.
Well,
okay.
My motions are faster than yours.
Let's see if we can just do this.
Oh, okay, yeah.
The second one's orange then. I was
Oh,
right.
yeah, okay. Thank you.
Cool. So now we get on to actually calculating the different metrics. So you've got some data like this. It's 3 different variables for 3 people. You've got different time steps, obviously. You've got 1,000 time steps. All you need to do, if you've got this in the right NumPy array format, is just fire it into this symbolic entropy function. And then you'll get the entropy for that window. NumPy, I hope, is familiar to people who use Python. So you just need it so that you have the variables as the first axis and the time as the second axis. If you know NumPy, I guess that probably makes sense to you. So this is like 3 by 1,000 rather than 1,000 by 3. Again, I hope this is a fairly easy package to use. There's also the possibility to apply the function in a windowed fashion, because this comes back to this idea of whether people synchronize sort of consistently or whether it's different at different times. So this will take a little moment, but here you can see the entropy progressing over time. So there's moments where it goes down quite a lot relative to the kind of background variations, and those are moments where you might say there's some additional order in the meeting. The system seems to be more ordered, and I guess you'd interpret that as a form of synchronization going on.
So are the higher values increased entropy, or okay?
Yeah, so lower values are lower entropy, which is more ordered. Yeah. Okay. So yeah. The next metric is the MDRQA. Here you need to create a recurrence matrix, and you need to state what radius you want to use, so how close points are going to have to be in order to be counted as recurrent. And the normal approach is to tweak this radius until you get a determinism of about 5%, or since I've output the proportion of determinism, which is the second value here, you kind of tweak the radius until this is about 0.05. And that, if you don't have any kind of theoretical reason to choose the radius, you just kind of set it like this, and that's kind of fairly accepted. I mean, obviously, ideally, there'd be some theoretical reason that you'd set it to whatever value, but you don't always have that.
Do you set it for the whole data set, or do you set it per group?
I think that would probably be up to you, but I would often, it depends what you're looking at, I think, really. It depends. I mean, if you're comparing the determinism between different meetings, you don't want it to always be 0.5. If you're comparing it over time, or you're looking at it compared to some event that's time varying, then you might normalize in a sense. This is that would be kind of like normalizing per group. Yeah.
That's kind of, on the face of it, it's almost kind of interesting to say, this type of team worked with this type of setting, and it tells us something about what we're looking at, right? That is, we couldn't make sense with that kind of setting. The radius, I guess, is what we're setting, it's going to be different. Right?
So yeah, the radius there would be kind of telling you like how close is close for this team.
Right. For this group, how close is close.
Yeah.
Yeah.
Yeah. Well. Yeah. Exactly. Yeah. Okay. I've not thought about it that way around, but I'm sure it's a possibility. Yeah.
I'm just.
Wim, were you still saying something?
No, I do have a question. So for RQA, one thing that when people start with that, such as I get overwhelmed about the parameters, right? And now you only have the radius, but are you also doing the tokens embedding kind of delay embedding, or?
Yeah, I left this out of this demo because I don't think people are going to use it, but it's there if you want it.
What's the automatic or?
Well, we don't use the delay embedding because there's, at least the literature that I've been reading suggests with multiple variables already, it's kind of hard to know how many times you should repeat 5 variables. If you only have one and you're comparing it to itself, then there's more of a basis for deciding that. But if you already have 5 variables or even 10 variables, then it seems like you maybe have enough dimensions to capture the full dynamics of the system already. So on that basis, you know, there's at least the kind of the academic community, I guess, has a word of caution about using embedding. But you can if you want. I mean, it's there in the functions. I just didn't think it was. I didn't show it in this demo. Right. So again, you can do it in a kind of windowed fashion. I think actually the MDRQA is the slowest one to compute, so we'll have to wait a minute or two for it to do this. I think it's the fact that it's windowed, so it has to do the MDRQA 1,000 times or something like that. Well, 100 and something, 120 times. Coherence and the sum normalized CSD are both very easy to compute. Again, if you have this numpy array, you just fire it into the function and you get back what you want. And I think even to do it in a windowed fashion, it's only that. So it's hopefully quite an easy package for people to adopt. Where's it get to, right? Yep, so the last two are the row and the test on the Kuramoto order parameter. So as I said earlier, they rely on phase. And the phase is a little bit of a discussion in itself, how best to extract phase. One of the simplest ways is using the Hilbert transform. So for the sake of a demo, I just did that. But you can also use wavelets. So if you have a complex valued wavelet, like the Morlet, or the Morley wavelet, then that will give you phase. And then there's also different methods that people use, like they look at peaks and troughs and they just interpolate between the peaks and the troughs and say that's one repetition. So there's different methods, and that's something that I kind of have to leave to you, I guess. There's no one good answer that I can say people should do this. At least here's a simple example of extracting phase. And once you have this, so the phase extraction gives you another time series. So you start with a time series that's amplitude, and then you get a time series that's phase. So it'll be actually an angle. It's always measured in an angle of rotating through a repeating pattern. So obviously like 0 or 360 degrees is completely going through the pattern. 180 is you're halfway through your repeating pattern. And you have this phase time series now. Once you have that, you can just put it straight into your into the row function. And row actually gives you two outputs. So the second output is an overall score, but row by itself also gives you per time step measurement. So it gives you the synchronization per time step too. It already gives you synchronization over time, but if you want to, you can do it in a window fashion just for consistency. So again, here we have the phase-based row, and it's just, you can see how it progresses over time for this meeting. The next thing I'm going to do is try and show you all of these 5 metrics I've mentioned so far on that single piece of recording. And in black, I've put the kind of the average of all of them. This is all the different metrics over time. And I think about 70, or window 70, you see that there's kind of an agreement between the different metrics, which I think is actually a kind of combination of some similarity between the people and also partly due to the fact that they're not moving around as much, which makes it easier for them to synchronize in a sense if everybody's not moving. In rest moments, that's actually often where these metrics jump up, so maybe that's something to bear in mind.
I hadn't thought about that, then having them sit actually removes all sorts of other, shall we say, vectors, parameters, noise, whatever. They happen to be sitting. It limits what they can do.
Yeah, and if there's a pause in the task or something, then people maybe just sit there quietly, and it looks like everybody's doing the same thing at the same time, therefore synchronizing. So, but then I think some of the other moments where it gets a bit higher, I think there's actually some activity, and it's more like people are really just sort of moving their hands at the same speeds or rhythms.
And one question about, and this is very basic. So you said you took the 1,000 first events. And what is on the horizontal axis? How can I interpret that when I just pop in this video? How can I know, okay, there is something happening at 70. Where is it in the video?
Oh, right, sorry, yes. So,
maybe it's me.
No, it's me. I skipped over something here. So I've been showing you actually the first 10,000 steps, sorry. And then I was analyzing it in windows of 1,000 steps with an offset of 500. So there are some parameters if you want to do it in this window fashion. It's like how big is your window, how far do you slide your window before you calculate the next value. So you would just do your 70, whatever it is, or 90, whatever you choose, and you just multiply by the 500 to see kind of the offset for where it's like how many times you slided it times 500 steps for each slide, as it were. Yeah.
And the 500 are the frames or milliseconds or?
Frames.
Frames.
Yeah.
Okay,
Yeah.
thank you.
So we can do some calculation there to say this is a time, the moment is this, right?
Yeah.
In our time code.
Yeah, that's it. Yeah, because it will be based on frames or whatever level of aggregation you provide to it. Yeah. But maybe that's something I can improve in the future, to have it give you the frame number rather than the window number. But it's also, I think it's just because this is how I've plotted it, that you could change the axis.
For sure, yeah.
Appropriately.
I just, sometimes the reviewers say this, I cannot understand, translate this to me, so that's why.
Yeah, it's a good question, yeah, it's a valid point, yeah.
Do you have an output that's the cluster bars for something like this, or do you need 3 different distinct states for that? Remember in the very beginning for this one, you showed here are 3 different players, as it were, right? One was like this, one was like this.
Yeah.
And then you plotted them all together on like a little bar graph type.
Yeah, the symbols, yeah.
The symbols, yeah. Is that possible to output out of this, or do you need 3 distinct states for that?
Well, this is based on kind of automatically taking each signal and individually splitting it into those kind of 3 high, medium, low.
Right.
But that's all kind of done behind the scenes, and then it gives you more of a simplified output, which is just saying, after we've turned it into high, medium, low for each variable, combined the variables into a symbol, then looked at the distribution and got the entropy, then the entropy is this. So it's kind of the end of all the steps.
Okay.
At the moment, yeah. Again, I don't know. I thought maybe it'd be easier to give simple outputs. But,
Sure.
maybe some people are also interested in that too. Yeah, so there's one more metric to show off here. This is the Kuramoto test, which hopefully you maybe remember I said that this works across a sample. So it wouldn't be just one meeting, it'll be all the meetings. And it'll be trying to tell you whether there is kind of above chance level synchronization, whether there's any interesting synchronization to look at, or if it's just a coincidence. Right, so here it's showing you the p-value, which is very, very small. And the t-statistic, which is very large, and the degrees of freedom, which is sort of somewhere in the middle. Right, there's also an exercise here, but I think I'll leave that for people to do offline after the presentation, and I'll provide this Jupyter notebook and people can go and do it themselves. Okay, so that was the 6 different metrics. Are there any questions? Because I maybe rushed over things a bit there. Yeah, go for it, Ben.
I have one question. So are we okay that we treat idle moments as synchrony? Because I feel like that's always a problem with RQA. It's actually reasons why I moved from that method and saying, no, not for me, because I cannot distinguish between order that is based on at least activity than order based on inactivity.
Yeah, at the moment, I mean, we're kind of focused on using metrics that have already been used in recent research. So we kind of were following the lead of other people there. I think maybe I have some ideas about how to approach that, but there's nothing that I've actually developed yet. So maybe in the future I'll try and come up with something. I think maybe what you could do there is compare the synchronization that you observe to what you would expect given the fact that they're not moving, or given how much they're moving, how much synchronization would you expect? But I'd need to come up with some maths to come up with a valid application for that. In the meantime, I'd suggest maybe you can just exclude things where the average movement's below a certain threshold and just say, I'm just going to ignore them from my data. It's like a kind of a, throw away some windows, cut some windows out, maybe.
Yeah, yeah, that's true. Yeah,
Maybe.
yeah, definitely.
Or
If you're
just,
not embedding, then it's no problem. Yeah,
So interesting, silence is noise.
yeah, yeah, yeah. Yeah. It's poetic.
I like it, yeah.
Can I ask something that's maybe directly related to that? So I was thinking about this as well in terms of you might have kind of theoretical reasoning to have, say, 6 different dimensions, 6 different time series that you think, I think these are going to be related, they might be recurrent, they might contribute to the overall entropy. But then it may be that actually you think one of them is relevant. One of those signals is actually not really contributing. So let's say with the recurrence that there are patterns that are recurring in 5, but then one of them is really just all over the place.
Yeah.
I think my question is kind of twofold. Maybe A, is this going to be problematic for your overall calculations? And B, is there a possibility to kind of have a step where you first determine which of your signals are actually meaningful, or maybe even to clean them out like this? I kind of maybe getting at the last bit of your previous comment, but I'm kind of thinking of how to deal with these kinds of things.
Yeah, so that would be not like the times that are bad, but the variables that are bad.
Exactly, yeah.
At the moment, it's not like there's a kind of, that I have a particularly well thought through, sophisticated way of doing that. I mean, one of the simplest options, I guess, is just if you have this hunch, try and kick that variable out and then recalculate your metrics. Otherwise, I mean, I think because all of these are driven by the majority or the kind of system level, or a look at the system level, I think that most of them will still, like, if the noise to the signal is in the small enough proportion, or the signal's high enough compared to the noise, they shouldn't really completely mislead you. But it would still be an impairment. Yeah, I mean, but then also, I mean, some of these things are kind of hard to interpret arbitrarily. Like if this has a synchronized, it has a entropy of 3, what does that mean exactly? So just looking at the raw values is sometimes it's hard to interpret that by itself.
Right, and so thinking about like where you had these splits into low, medium, high, for example, this might also have been basically the same question that Jonathan already asked, but is it possible to get like or maybe relatively straightforward to get an output of, let's say, what are the major recurrent patterns? So if you have a particular MDRQA, you have a set of statistics, right? Can you also then get out of this and say, well, this basically comes about because these patterns are highly recurrent. Let's say person 1 high, person 2 medium, person 3 medium, and say this is really recurrent. Person 1 or all of them high, high, high. This is very not recurrent.
I'd say that the kind of the lower level functions for MDRQA and symbolic entropy, I think, are in the package, but not kind of the main bits that I'm showing off. But I think you could probably take what we have and fairly quickly put something together to do that. But it's not like there's a single function that gives you exactly that input. No, but the thing to convert it to the terciles and to combine those into symbols, that's kind of there in functions that you could call, and then it would be kind of maybe up to you to see which ones are the most recurrent. Just know how often do they occur and rank them in that order. Yeah.
Yeah, that makes sense. I can imagine that could also be helpful for that figuring out which signals maybe aren't contributing. If you see that there are 2 really similar patterns, but then that 6th signal, let's say, is kind of...
It's always this variable, isn't it?
Yeah, exactly. And then you could just say, well, I dropped that, and then we collapse these 3 patterns into 1 pattern because it didn't matter.
Yeah, no, that's a really good point, actually. Yeah, I completely agree with you. Yeah. Cool, that's a great idea.
Something to work on. Thanks.
No, cheers. Cool, very good questions. Right, so I'll just move on and finish this off, and then we can have some time for discussion. Right, yeah, so one assumption that I put on the screen earlier, but very briefly, I didn't really talk about it much, is that the Kuramoto test has this assumption that the variables, each of them individually, has a relatively uniform distribution of phase values. Yeah. So that's kind of like saying that they have a kind of fairly consistent way of progressing through their patterns, which isn't always true. So I'm going to kind of show it here that in this case, it's quite skewed. This is in radians rather than degrees, but you can see kind of on the edges, it's much higher than in the middle. And I think this is pretty much due to the fact that there's short bursts within a background of it being quite flatlined. So the progression through the pattern isn't really happening when it's kind of flat, and it progresses really quickly through these sudden bursts of activity. Because this assumption has been violated then, actually the Kuramoto test, which I showed you, probably wouldn't be that relevant or wouldn't be appropriate for this data. So then the question is kind of what else can you do in that case? The common approach, which I think is a very good one, I think is very valid for all sorts of, well, pretty much any research into synchronization should consider using surrogate data. So we give two ways to come up with surrogate data, which is kind of using your existing data but rearranging it in some way or using its properties to create fake data and seeing, will the fake data synchronize too? Or will we get high values of synchronization in our fake data, even though we've got people from different meetings being put together? Do people from meetings where they weren't even in the same room on the same day, do they still synchronize to a certain degree? So it gives you a baseline to compare your observed data from the actual recordings. The baseline is created from these surrogate or spoof recordings. The one that I've got in the demo, question?
That's fascinating. Like you're creating basically a synthetic database, a data set in order to say, oh, okay, how does this do it? So you, on the one hand, you might create a homogeneously distributed or regularly distributed some kind of motion pattern per se, and say, so this is actually a evenly distributed. Kuramoto would work with it because it fits the bill. So do things go against that? Or are you saying you would take real random stuff and say, well, this is random, there's no way there can be synchronization. And compared to that, this is synchronous.
Okay, so maybe I skipped over something that was important. So this wouldn't be for use with the Kuramoto test. In a sense,
Okay.
we've accepted that isn't quite appropriate because of this assumption. So instead, what we're going to try and do is compare the other 5 metrics between the empirical data and this baseline data. So we'll see, is the entropy higher in the real data compared to the baseline data? Is the row higher? Is the MDRQA, so percentage of the determinism, is that higher in the real data versus this baseline of spoof recordings or surrogate recordings? So probably called, So there's also functions in MultisSyncPY to do this, because I think it's something that people will probably want to do quite a lot. Here, the approach that I'm taking in this demo is to take the variables, so in this case the people, and kind of put them into fake teams. So we'll put person A from day 1, person D from day 2, person G from day 3. We'll put them into a group, and we'll see if they synchronize, even though they weren't in the same room at the same time. That'll give us a baseline, and we can see if the real recordings have higher synchrony. And really we're just asking, is there any interesting synchronization going on at all? Or is there nothing to really investigate in terms of synchronization in this data? So thankfully we find out that the surrogate data has significantly lower synchronization. Which one was I using here? Coherence. So using coherence, for example, just as one of the metrics you could use, the coherence is significantly lower for the surrogate data, which suggests that there are at least some moments that are not due to coincidence, some synchronization moments that aren't due to coincidence. And I guess my last point here, because I think I've seen a few people ignore this in papers, and it always annoys me. I think it's always good to use surrogate data like this. So even if you're not investigating this specific question, maybe you're investigating, does synchronization drive good outcomes? Does the product that you designed, is it better in some way because you synchronized?
Right.
I think you should try and run that analysis again with surrogate data, and if you still find the same result, then that's a bit perplexing, because you think, why is there this relationship in my fake data too?
Well, that tells me we just use random shit and
It still gave us the right answer.
Yeah.
Yeah, great. Yeah, so that's a bit question begging if you find that.
I'm wondering, one of the things we did when we put together the data set, when we put together the cases, as it were, what we noticed, and it was very small and very anecdotal, but it's the direction we went, was that if we started everybody on a engineering drawing and they could break away from it, they had more radically different results than if we started people with a vague prototype, shall we say. So I'm thinking now that in a sense, we got them all on the same page in the same way you would if you're playing jazz, a certain kind of jazz, not the Albert Ayers type, but you all start with a head. So there's a level of synchrony, and then you go off and do other things. And then there are moments where you come back and then write. And it's remarkable. Whereas if you're just playing whatever I want, whatever you want, this and that, it could just be a bunch of different signals rather than having started with a similar reference point. So I'm wondering if synchrony can be seen in saying, let's all start with something very definite and then begin to pull it apart from different points of view. I'm in terms of the behavior we're watching, right? Because then you have a lot of various types of things going on, but you always come back together and saying, okay, so where are we now? What is this thing we're at now?
Yeah, I think this is a wonderful opportunity to use this MultisSyncPY package. Yeah,
That's right.
absolutely. Yeah, I think that's a really interesting question. Yeah, I guess you need to operationalize some of the things about the kind of the outcomes, or how to map it to, yeah, whether people are actually thinking in a diverse way or not, for example. But yeah, I mean, trying to find some relationship between synchronization or moments of synchronization and a kind of a process that's going on within a team or an outcome from a team, I think that's a really exciting line of research, and there hasn't been that much done on it, I don't think. So I think that would actually be, yeah, very, very interesting line of work to do.
I have another thing up on the board there. It's did you see the 4 verticals play?
No,
Probably not. In the very beginning, one of the things we look at is how American football players, it could be any football team, they have a play, and there's a play called the 4 verticals play. And everybody has the plan, but the plan goes awry because of all the interference and the blocking and the, from defense. So I'm wondering, what are the moments of synchrony there? And I mean, there has to be some kind of synchrony because someone's catching that ball, right? Or it's thrown into a place. But there are 4 chances for that, but one choice is made based on what's going on. It seems like if there's synchrony there, and there has to be some kind of synchrony, that it's very complex, like trying to figure out what that is. Does player A, B, C, or D get the ball, given all these other conditions that are going on? Are we saying they're all synchronous, but there's one choice made then at a certain point?
Well, I think this is really another very good question, or a very good idea, but also one that's hard to give a really perfect answer to.
Yeah.
Because I think you're already getting into this question of like what's observing a phenomenon that's happening, kind of like a pendulum swings back and forth, kind of inevitably. Whereas here, the quarterback might make a decision based on the fact that this guy's synchronizing with me, where the synchronization would be deriving the decision making rather than it's just happening, and that in turn will determine what happens next and so on. So if it has a role in the kind of agency or the decision making of people that then changes what the next observation you record is, actually just from a kind of general methodological perspective, that's the difficult thing to establish. Yeah, I don't know. I guess I maybe have to leave that as an open question. But maybe people from you've got more experience with doing these kind of human-centered studies would have their own ideas about how to do this. Like, how do you understand causes and effects when, you know, one action is causing another action, and some things are both a cause and an effect, and so on. Yeah.
Thanks. That's great. Yeah.
Well, thanks so much for these comments and questions. They're really interesting. Yeah. Thank you. That was the end of the demo, and pretty much the end of the slides. I had some. I don't think I have the time or the need to really go through at this point. So we do have a paper that describes this in more detail and some experiments that we did. And I'll leave the link on the screen for now, and I think we can send it out through mail or whatever. There's the code on a certain repository. If you just want to install it, you can do pip install MultisSyncPY, and it will appear on your laptop. There's my email if anyone wants to get in touch. Obviously, we're trying to promote collaboration, so please do get in touch, of course. And yeah, there's a quick acknowledgement there about the funding that we got from the Dutch Research Council. And then I'll just kind of open it up to questions or comments and discussion for, I guess, sort of 15, 20 minutes.
Yeah. So this is maybe anticipating a little bit the next session because I will have to run away, but mine are just a few open comments maybe about research, because I find this very thrilling and I will try to use it. I'm not so much into the metrics, but about synchronicity, no? I mean, I have 3 open questions. The first one is about intended or unintended coordination, in the sense that I'm wondering if we are able to make in this kind of research a distinction between when we want to synchronize and when this is subconscious, because when we study team performance, this could make a difference. The other one is about what is synchronization indeed, because if you think of Jets players, right? They do all different things, but still they share a sense of empathy and confidence. And so we can say they are synchronized even if they are acting differently. And so this is also, can we adjust these metrics to consider that there could be such a difference in synchronization? And sorry to spam, but the third one is that if I think of flow, I think about flow and synchronization as an oscillating dynamic state. So even when we do it in social network analysis, we think of rotating leadership and this kind of metrics. So here we look as a continuous at synchronization. But what I find sometimes, it's not that just maybe we synchronize for a while and then there is a sudden change. And it's more important to only look if we synchronize in that moment of change than overall the full period, right? So this is something else I would like to explore. Just ideas and open comments. I don't want to bother too much, but
no, cool. It's quite all right. Yeah. Which order to address them in? Okay. So the first question was about intention.
Yes, and intentional and unintended coordination. Yeah.
Yeah, I think one of the things that's interesting, or sort of generally there in the discussions of synchronization, is about whether things have a tendency to synchronize, or if you, for example, set them off at different starting points, will they naturally, synchronize later on? Will they drift towards each other or away? So I think maybe intention you could analogize to that. It's not going to be exactly the same, but you could maybe see if some teams seem to favor synchronization, and it seems like even if you disrupt them, they try to go back to a synchronized state quickly. Like how they respond to disruption might be an indication of intention. And unintentional, maybe if people try and escape from a synchronized state as quickly as possible, that thing, if you're trying to get past someone in the corridor or something, you're trying to get away from the synchronized state. So I think maybe you can just have a look at what preferences people seem to have, and whether they try to move towards synchronization or move away from it in general. That's my first thought on that. But I don't know, maybe some more time would be needed to think about it more thoroughly. Yeah. I can't can't even read my notes now. So, just about what is synchronization. You mentioned jazz and whether it has a certain role in changing or transitions. I think that's a good point, and I think it's not something that I can say definitively. It has been proven by anyone at this point. I think the kind of the role of synchronization is something that hopefully quantitative methods like this or packages like this that make it easier to calculate synchronization, hopefully they'll support this type of research. But it's an open question, like what is the role of it? It could be for social bonding in teams, but it could also be for efficiency in teams. So yeah, it could have different roles in different contexts and so on. And I think that's a good question, but I think maybe I'd leave it to you to formalize that research question and actually investigate it. Yeah. The last one's about flow and kind of oscillations. So are you asking about whether the system oscillates or whether the degree of synchronization oscillates?
When there is change, a sudden change in a regular pattern, then can we adjust these metrics to only look at what happens in that moments? And because the other things could be noise, right? I mean, not noise, but the signals could be in specific moments. And so maybe looking just at the moments could clean the message or the metric that then relates to performance or other dependent variables.
Okay, interesting. So I guess that would be looking at kind of like extreme desynchronization kind of. So yeah, I mean, I think for some of them, like the entropy and the multi-dimensional RQA, the MD-RQA, I think, yeah, maybe you could look at moments where they seem to be highly desynchronized. That could also maybe help with that sort of question. Yeah, I think for those metrics, maybe it's probably it would be appropriate. Maybe for some of the others too, you can maybe look at this. Yeah.
Thank you.
Thanks very much.
That's a really interesting notion. Are we looking at a system oscillating, or are we looking at the degree oscillation in some of this stuff? I don't know. I'm not even sure where to begin with that, except to say a degree of something oscillating. We could look at, well, here's a degree of oscillation in hands, for example, and then the system oscillating means it's like we have a whole new type of thing that's happening, right? As opposed to quantity, we have a whole qualitative shift here. And is there an oscillation between these qualities that we then give a number to and it becomes a degree of something else?
Yeah, I think that would be almost like a follow-on step or a next step after looking at synchronization would be kind of looking at, I don't know, an idea of phase and a transition between different phases of behavior for the system. Synchronization could help you look at that because it would look at, give you an idea of the patterning, but it maybe wouldn't tell you that you've transitioned, or it wouldn't specifically tell you that at this point you change from one patterning or one type of patterning to another type of patterning.
So something we've noticed in that respect, we've developed something called MEDKI, which I'll just talk about part of it, but it's the way we see effective teams work through, and it seems to be a change of phase, not just, a change of qualitative phase. And so one is disrupting, and we've noticed that the woman in there, she's a brilliant disruptor. She'll go, what if you could throw it? What if you could break it? What if you could do this? What if you could do that? Not looking for a solution. What if it's for the UPS guy, right? And she's a lexicon of these things. And the other guys, one seems to do a lot of what we call gestalting, that is just roughing it in. And well, it'd be kind of like this. And the other guy goes, ooh, then the button would be here and the strap would be here. And we see those as three distinct things in many ways that follow on each other. I would see those to be big phase oscillations rather than degree of anything because they're qualitatively different.
Right, yeah, okay. Yeah, I think in a mathematical sense you can kind of try and relate those maybe through attractors, that you can say that this attractor, you've fallen into it and now you're within that could still allow you to display a wide range of behaviors, but you would be specifically in one attractor or another, or the attractors change over time and a different pattern emerges due to that. Yeah, I think it definitely does make sense to say there's a kind of system of patterning and that can change over time. You can be in one system of patterning or another. And you can see that with all sorts of things, like even walking versus running. It's two different ways of organizing, quite rhythmic movements.
Right.
And they're different, obviously. Yeah, there's not, I mean, maybe you could come up with half walking, half running, but it would probably look weird and not work, right? You tend to end up in these kind of specific attractor states that are more discrete than continuous, like you're saying.
That's very
We
interesting.
have a question online from Julia.
Yeah, please unmute yourself and ask if you can. Yeah.
Sorry. It's kind of coming back to the question about synchrony and because you mentioned at some point ratio signal and noise, and often we want to get rid of the noise, but I think there is new evidence now that the noise is very important to not be stuck in sync, kind of, and it's kind of help to move in and out of synchrony. I'm thinking about a recent paper from Mayo and Gordon talking about that. I was just wondering if it's something that you, plan to implement at some point in your analysis to see to what extent, the system is not stuck in sync, but can move from one state to another thanks to the noise. I'm thinking about the peak noise mostly, because I think that's the one that is mentioned in the literature.
Okay, so this is kind of like a disordered period is needed for transitions between phases. Is that the kind of the theoretical background there?
Yeah, kind of. It's more the idea of metastability. I think has been suggested by Scott Kelso, in the sense that it's better to be metastable than stuck in synchrony or asynchrony, let's say. But this idea of flexibility, so this possibility to move and this capacity to move from one state to another, might be due to the noise in the system.
Yeah, absolutely. Not in this particular piece of research, but in other pieces of research as part of the same project. Yeah, my collaborator Travis Wiltshire, who's kind of the head of that project, he studied with Scott Kelso, and I think Kelso was his thesis supervisor for his PhD and stuff. So Travis is definitely into this kind of thing. And in other pieces of research, we were looking at something called dynamic complexity, and that is analogous to something like entropy. This dynamic complexity is kind of looking at how chaotic or disordered a system is, with the idea being that you tend to have these high periods of disorder and disorganization that kind of enable a new order or a new system to appear afterwards. So not within this specific context of the synchronization package, but in other projects I've looked at that, How it associates to this, I don't know right now. I think I'd need to think about that more, really, how to integrate it with this. Because this isn't directly getting you to which phase you're in. It's more like a kind of, it's like a proxy. It's in the same ballpark, it's associated, but it's not quite the same question exactly. So I think it'd be interesting to find a bridge to looking at phase transitions. But I don't have like a kind of methodology to hand you on that one at the moment.
Can you say the name of the researcher who talks about that there's this breakdown before you get a new one?
Oh, I think there's a few people who talked about it. Kelso was what Julia mentioned.
Okay.
And then I'm going to have to remember the name. Strong, is that it? But dynamic complexity, if you search for dynamic complexity, that comes from actually context of psychoanalytic treatments, or therapeutic treatments anyway, and looking at whether sort of self-measurements of emotional state, for example, if they become chaotic, does that suggest an impending phase shift, maybe towards a kind of a depressed state from a manic state, for example?
Okay.
So that dynamic complexity would be the other thing I'd suggest maybe looking at.
That's very interesting. So it's kind of chaos as a precursor to a new state.
Yeah, chaotic in the sense of disorder, I suppose. Yeah.
Okay.
I don't know if that's any relevant, but it just reminded me of something I find pretty perplexing. Nonlinear phenomena in speech. they are communicatively relevant in that sense that people can perceive the degree of pain by through nonlinear phenomena. They are in the sense iconic, they transport meaning. So if there is more of these phenomena, there is more pain. So there was a team of researchers who tested like mild pain when I hit myself, right? Then I say, oh, or ah. Then some moderate pain when you maybe get a bigger cut, and then women who are giving labor, just like extreme pain, and people could, they analyzed it, of course, also, but people could really guess the sense. Of course, there were degrees and everything, and they could guess how painful the thing was on the scale. And they said this is because of the nonlinear phenomena. So maybe chaos, in this sense, has meaningful properties. But it's not in synchrony through two people. It's like more on the sense of perception from a signal, a single signal.
Yeah, I would say there's definitely some associations there. I'm not familiar with nonlinear. Is nonlinear in like how one thing scales with another, or nonlinear in the sense of how people interact? Or...
I can't point to, but I think it's not that we have a nice oscillation like with vowels or something. When we have a scream, and it has a lot of noise in the signal, it's not very...
It's not some pleasant overtones.
Yeah, it's not so synchronous, it's not oscillating so nicely. So there's a lot of non-linearity, I think. Right? So Andrei Anakin, he was doing this research, and there were some really good papers. It was just a thought I got now listening to you and Julia talking.
Okay, I mean, like absolutely another interesting research direction to go in. Yeah. So this is kind of like how disordered the sound wave of the scream is.
Yeah.
Yeah. Okay, I've never heard that before. That's really interesting. Okay, cool.
Do MultisSyncPY on that, on screen data.
Screaming, people screaming together. Like,
yeah.
Do you have ethics approval for this?
Yeah, and maybe I have one more question then.
Yeah, super.
So we're moving away from individual to multi-party group. So, but also with a lot of these techniques, I wonder if we already can account for diversity, and maybe in the simple way that you have three oscillators that have different temporal scales that are oscillating, and the only thing is that they are in phase at a particular moment. So one at 1 hertz, one at 2 hertz, one at 3 hertz, and they are polyrhythmically coupled. But if you do a Karamoto, you're continuously checking the phases, so that you won't see a lot of synchronization. Or is that true or not?
I think with Kuramoto, you probably wouldn't see synchronization there. You'd realize that that's random.
Yeah, and I'm thinking about RQA, it's the same, because then they're not occupying for a good enough time the same states, because they have different temporal scales. But polyrhythmic coupling, we perceive it directly that it is coupled, right? The entropy wouldn't show up. So I wonder, is there some generalization where you can account for the diversity of the different temporal scales? And especially for multimodal, for example, I did cross-wave analysis on speech and acceleration of the hand, for example. But still, it's difficult. They're not operating on the same scale. Speech is so much faster. And maybe you could take some derivative of your other signal together on a similar scale, but still, you're dealing with systems that have intrinsically different time scales, but they can still talk. They can still be timed together. But that's like a real challenge to deal with diversity of oscillators while still saying whether they're synchronized or not.
So it's kind of like the overtones if you pluck a guitar string or something.
Yeah,
right?
yeah.
There's someone who's a multiple or a power of 2, multiple of another signal. I think for some of them at least, like the MDRQA and the entropy, I think you would see lower entropy if you have like 1 hertz and 16 hertz versus 1 and 17, right?
Yeah, okay.
Because they would be in phase at least more of the time. And they finish their patterns. Or you could quite easily analogize between the 16 repetition pattern and the 1 repetition. So I think some of them you would oh, sorry, go ahead.
You can also adjust the coherence probably to say, well, integer multiples of one dominance frequency that's going to be seen as coherence.
That's an interesting one. Yeah, I think you could use coherence to do an analysis, but I'm not sure if in its current form in the package it would be that good for it. But yeah, certainly you could compare different frequency bands. Yeah.
Okay, so symbolic entropy actually would be sensitive to that, so that's good to know.
That's what I would assume. Yeah, I would test that out, but I think it probably should be. Yeah, I think it would have reduced entropy compared to if it's not some power of 2 relationship. Yeah. Awesome. Cool. Do we have any other questions or not? I think we're good.
Yeah, I'm sorry to. We're having back chat about this, and we're trying to. Oh, thanks. We're having back chat, and the back chat is about. It's about the Sun part, and about decoupling it from the Chronos part. And it seems that some of the, even though these are based on time series and synchronicity has to do with time per se, maybe the same tools can be used, and instead of using time as your Y, something else is used as your Y. And then we have a Sun S, right? And it could be intention, belief, frame. That is, there's a type of metaphorical synchronicity without the Chronos part, if we share the same frame, right? We're all on the same page if we share the same frame somehow. And so maybe we could see moving through frames, or you start with a frame and say, well, here's our frame. And in the case of what we're doing, the shared frame is the data set, right? And that gives us a way of being in a certain kind of step while not being in step in other ways. And I don't know if that precisely has to do with time. It has to do is that we're situated with either a theoretical frame or a methodological frame or a domain frame or a data set frame. And I'm just, because I'm thinking about what these guys do is, I didn't do the math for what the 1,000 frames was to see where they are, and I'm totally interested in figuring out what that is to see, oh, they're doing this here, or they're doing this here, of course. But, you know, again, you know, in terms of, I know one of the guys says, yeah, when we look at this, it's like playing the head. Now, are they playing the head? No, but they're looking at the same thing and all talking about it and taking it apart in the beginning. There's some people who get stuck on that and never move off of it, and nothing happens. So they never move into diverse frames, like, you know, bringing chaos in, right? What I'm beginning to entertain is the notion that when they start to disrupt, she's bringing chaos into the system, right? And that's healthy in this case.
To move on from a pattern, yeah.
Right. And I'm not sure if that's a time-based thing per se, as there's some notion of going through different frames, right? Now we could say it's with time, and I'm not saying it's not, but I'm just wondering, can we use some of these tools to begin to think about Sun something else, Sun frame?
I think the thing there is, I mean, I'm not sure on that one. I think this is more for fine.
This is
more
like killing Galileo.
I think.
This is like killing Galileo, right? I mean, right? Well, that time thing, let's get rid of it.
We don't want all this high resolution data. Yeah. I think for this, maybe it would just not be enough data points to do, unless you have an incredibly long meeting. Yeah. So I have to disappoint on that one.
Okay.
But it's an interesting conceptual question, even if this package isn't the one tool for it.
Right, because this one is totally set up for that. But maybe some of the methods that you have of the 6 methods saying, well, let's take away the time part. We're not going to do this, and this is one of these you tell I went to art school, right? It's like, well, what if you get rid of time? Yeah, what happens then? Right, but there's something there. There's something. Okay, thank you.
Thanks very much.
Now,
Yeah, thank you for your questions.
so,
Microphone?
yeah,
That was fabulous. Thank you.
fabulous.
No, I'm really
So-
glad everyone liked it, yeah. Thanks for the questions.
I'll try to fix it. You know, Joaquin, when are you leaving? When are you leaving?
In 10 minutes. But
Andrew, when are you leaving?
I think right now, more or less.
5 minutes?
Yeah,
Okay,
5
fine.
minutes. Yeah, yeah,
Yeah, so we wanted to just put,
group photo too?
yeah, it's here already.
Can you stop sharing?
Yeah, sorry, I forgot. I'm just going to do it now.
Okay.
Yeah, we
keep
need
me
to
up.
do SPS for Envision.
So I think I could put that on that side.
Okay, yeah.
So Andrew, just come forward. So the marker is the magic wand. It's an open space. Just let us inspire you for what SPS for Envision could be in terms of a research paper idea.
Yeah.
Yeah, you could start with things you have in mind, but also we just chip in.
Okay, so writing a paper about the SBS and Envision together.
No, like if we apply SBS as a SBS for Envision, what would that be like? What do you already have in mind plainly, and how could we collaborate to work on that?
Yeah, I mean, and I would be even more glad to collect ideas, right?
Yeah.
But so I like this idea of gestures and synchronicity that we heard at last. So I'm thinking of being synchronous in terms of semantic content and the value that you attribute to gestures in terms of semantics. So I would say SBS, semantic network. Synchronicity. I don't know, how do I write this in English? Sync.
Yeah, just sync.
Yeah, just let sync. Well, I would just put the sin without the C, because
Okay.
you've got, I mean, unless you've got a time frame there.
Okay.
It's fine, yeah.
Let's do like that. And then I would say similarity, because it's another way. It's more naive, but something that. And then I would say gesture injected into text. This is really something. So
Injected.
into text.
Yeah.
And then I would say SBS is a plus, so it's as an additional feature
Mhm.
to multimodal. So you combine all the modes that you have been seeing.
What
And
data?
yes.
What data do you need? For that?
Well, for this one, let me change the color because red again. Okay. So yeah, here I would need like a CSV file, time-stamped, and also with team code. And well, I won't repeat it, but gestures should have a code, should have a meaning into text, into the text. And also, it would be nice to have, I mean, to design together word clusters. In the sense that what is interesting for us to look at could be performance, could be design, could be some sort of emotions. And so if it's a pre-made construct, I have my own ideas and dictionaries, or I know how to shape it. But if within your context, which I don't know so much, you find that there is some dimension of the language or some dimension of the behavior that is particular, we should, I mean, this is the aligned with the talk of before, right? We should theoretically define this concept and then we put it in the data somehow. So this could be.
What do you mean by gestures into text?
Yeah, that you, for example, I'm saying something, I'm saying at the word something, I did this gesture.
Yeah.
And then so I would have my speech together with a word that is, I don't know, gesture number 3.
Okay.
Together with my word, right? And then I keep going.
Yeah.
Because then I can also build a brand image of the gesture.
So it's almost, I'm thinking about this as a function, right? If we have a function, X function, and it's the gesture function, we would have different things we'd feed into that gesture function as parameters, different values, right? And this would say, well, this is such and such a gesture. It has this, it's this function. It has these parameters.
Yeah, but do you want to go to categorization again, or do you want to give it a? Well, do you want to say this is an enactment gesture and this is an? Or do you want to have a gesture ID or?
But yeah, I mean, that's really. Is it velocity? I mean, maybe what tells us the gesture is velocity, a category. Attack, etc., or space.
So you could have a vector with
space
features
1, 2, or 3.
for that gesture.
Yeah, but it could be better that in order for me to process it in the simplest way, it could be that we have multiple transcripts, right? Yeah. So in one you have a code for the gesture. I don't know. It could be raising hand, and you put or gesture category. In the other one you could have a value. I don't know, S10. Which stands for speed 10, or something like that. And so then I can figure out and see. Yeah, but well, speed. I mean, if I analyze it through other methodologies, you can give me continuous values. But if I do it with the SBS, it would be nice to have, I don't know, speed. We could have low, medium, high. Because otherwise it's too complex.
Where do you locate this in text? Is it the initiation of gesture? Is it the target is reached, retraction, and so on? Where would you locate it? Because a gesture, depending on the gesture, it's different. It has some gestures very long, some are like I started, but then I retract. But maybe meaningful. So, what would be your idea?
Yeah, we should think
that?
about it because if you put it in the text, it should be someplace, you know. Because if you put all along the way, then it's so when it first happens, for example, could be an option. And then if it's a multiple gesture, like you give and retract, then it could be give and retract. So you have 2 codes for starting and ending that. So that could be something.
That's the difficulty of the different timescales, huh? That you have like gestures that can also operate in the sense that you hold the gesture while you continue speaking, and that hold is really meaningful throughout. That becomes very tricky with these kinds of things.
So we could also think of some gestures that you can hold can have like an old label. So like raised and hold, I don't know.
And Andrea, you would suggest that you have new kinds of, words that are not associated with gestures, and they will have a different position. It could have a different position than words that did occur with gestures, and they have their own multimodal.
Yeah, I mean, I want to see which words are associated with which gestures. And when we calculate the semantic trend score of the gestures, if that gives an indication of performance or learning behavior, and so it's combining the two. Likewise, I would be interested in better looking at the networks you presented yesterday.
You could do the same SBS on a network representation of the gesture networks, right? I think that would be.
It would be cool because there, even if it's not the SBS, it's not the only thing that I use. So I could do some network analysis with my tools on your networks and see what happens. So they are pretty dense, I've seen, but maybe we can simplify them because sometimes when you calculate centrality or other metrics, if they are almost full connected, then it's pointless. But we can work on that.
In terms of categories, is there a way of doing that? Not by eye. At this point, I'm just thinking, if this is an enactment gesture, if this is a metaphoric gesture, I'd have to look at it.
Well, you have the kinematic features that are each, let's say.
Oh, they do have kinematic features.
Well, if you have a list of features, it's basically just an arbitrary code, right? Doesn't, so that is something you could use, I guess.
Yeah, I mean, a list of features, you mean the code of the gesture?
Yeah, a gesture has three sub-movements, has a speed in the higher category, and is has a certain jerkiness or whatever. And these are, you can have a code for that, right? Like
yes,
you said.
But it's more, I mean, just because this is not deep learning, we want also to make a meaning. If you, for each gesture you have too many features and possible variations, you know, it's not necessarily the best case. So it would be if we simplify to the meaningful. So for example, I don't know, I've seen the video. There is one playing with something and the other one is riding and the other one is doing, so I don't need 10 different gestures to say that the person is riding. The other one is steady. So if he is steady like this or steady like this, could be different, but you tell me if theoretically speaking, it makes a difference, or if we can just say that he was steady. You know, I would start with the simple and then maybe refine, but let's see what we find.
I think you're back at coding, or you need a classification, machine classification.
Yeah, exactly.
Yeah, more than a list of features, because then I need to analyze it as if it was a word, right? And so, and if a different gesture is coded different ways, I mean, you can do that, and then I put in a cluster and I look at it all together in a first step.
And gesture, no gesture, just a basic difference between a word that co-occurred with a gesture or not. Is that already interesting or not?
Yeah, I mean, we look at co-occurrences in a direct sense, but it would be nice if I can rebuild all the network with the transcripts. So it's not just a bigram, right? So a simple co-occurrence, but I would like how the shape of all the network, because then I can see if some gesture is bridging concepts or not, so I can do more complex analysis. So I would need the full transcript and not just a list of pairs, you know?
These are doable, I think.
I think so, yeah. Probably should also consider, I don't know for sure how it goes in the video, but then for some gestures, it's a lot easier to say it pairs with something in the speech directly than others. So like representational gestures, pretty straightforward. Pragmatic becomes a bit more difficult.
Yeah, the problem is that,
interactive gestures, even less so.
Also with the representational ones, it's not just one thing in speech, it's usually multiple things, so that's even more complicated.
and they don't have to co-occur in time either.
No, exactly. They don't necessarily co-occur in time. If you think of the pragmatic ones, they may not, they may co-occur with some words, but not directly relate to those words or to the overall, what I talked about, I think yesterday as well, to the overall utterance. But that might be a reason to focus more on the semantic aspect of that. Just, I mean, we can't have every single thing in these analyses, right? So think about the semantics of the utterance and say, we're going to take the semantics of the speech. We're going to take representational gestures that have some sort of semantic mapping and use those for this type of analysis. I think that's also quite fine. We have to kind of focus in some way. And it's a little bit easier to get that mapping.
Yeah, and also we could look at time series and bring it back to synchronicity and see even if the semantic brand score of that gestures or that emotions across time, even if we don't inject gestures in the text, we could combine synchronicity time series with synchronicity in the speech. And so we could build semantic similarity at different time frames. So this could be another thing. So I would say. So even without the SBS, we can look at how this evolves and if it couples with the others. Sorry that I won't be here for other ideas, but I left you my
Yeah.
emails. So it would be great if we stay in touch, definitely. And yeah. No, I mean, I can stay a few minutes more, but then maybe you discuss more things, and it would be nice to know. I will look at the recording.
Awesome.
Definitely.
Yeah.
Okay.
Thank you.
Thank you very much for the invitation. I was very pleased.
We want to take photos quickly because everyone, Kim is also going.
Is there maybe for the audience online, should we?
I tried to bring up the entire thing, but
But
Can you-
the people have their cameras off.
Yeah, can you just
So
also
maybe-
help us manage the gallery view here? I
Yeah,
tried.
this is the gallery view.
Yeah.
Alright. But yeah, thank you, Alina, for turning the camera on.
also
So we
my
invite
camera
more people to turn on their cameras. That's great.
we can do a group photo.
Look, so many people still here. Are you alive? Still alive. Okay, good. This is the final of the bootcamp. And I think that's not going to be the final of our cooperation. And we hope, to continue this journey.
Yeah, I think what's important is that maybe it's difficult to get a real discussion with all of us right now. But if you, for example, have ideas about the Envision dataset, or you want to work on a project, or even like on the Envision toolbox, right? Want to add a module, like we said, we really hope that this is just a kickstart of.
So I still want to make those,
you're still
those
gonna do-
announcements.
yeah.
I just wanted to take photos.
Oh, we're first gonna make a photo. So sorry, you have to wait for us.
We probably have to come to the side because
Okay.
they're behind us here.
Yeah, we're gonna make a photo with all of us.
So everyone turn on your camera for the group photo, family photo, I'd say. Right? Nice. Can you? Yeah, definitely.
I can stand right in front of you.
Sit so that I have everybody in.
I'll pull up a set.
I heard that you're already blocking that one. Okay.
Does that work?
Okay.
Almost everybody.
You sit here, you sit here.
Can we take off the mask for the photo?
Yes, please.
Yes. Wow.
I can't see your face.
Yeah.
Of course.
Yeah.
Please smile.
Yeah.
Please.
We take masks off? Yeah.
Yes,
Hold on,
please.
hold on.
I
Not the
will
glasses.
just
That was the moment everybody got sick.
Yeah.
Say Envision.
One more photo.
No
Family.
paparazzi stuff.
Smile.
I hope you're smiling.
Yes. Thank you.
Thank you.
Thank you very much.
Oh yeah, we had a clap. Thank you.
Thanks, Andrea.
Thank you.
Multi-species.
It was great.
Yeah,
Thanks a
we'll
lot.
stay in touch. We're still going on with the reflections. Some people are leaving from here, so that's why we just did the photo thing very
Thoroughly
fast.
enjoy events.
We're happy that you're still there to join us. So we have research ideas for SBS for Envision. The next thing would be MultisSyncPY for Envision. Should we quickly do that, or we should go first to AI for Envision?
Yeah.
Sorry, what's the deal?
You go
So we kick
Yeah. Okay.
So now
I totally agree.
because it's still fresh in the mind, there's already a lot there, but don't even mind. You have your
People to understand to explain this.
you have your magic wand. Just research paper idea that we would all just chip in together and do.
Okay, well, there's some stuff already written here, so does anyone want to explain what's already here?
No.
Okay, I just have to guess what this is, right? Or you want me just to give some of my...
Just give some how we could collaborate, work together. With Jono possibly would love this. Maybe Andrea would also need to say, because maybe crazy journals might want this kind of crazy stuff. So
I think for me, like, the collaboration would be most exciting with people who have some theoretical background that I don't necessarily have. So people who understand design processes maybe know what to look for within the qualitative side of things and match that to something quantitative. So can you even predict things, or can you say synchronization is related to I don't know, more diverse thinking, or is it related to people getting stuck in a certain way of thinking? This kind of thing. So linking it to theory and trying to understand the role that it has, I think would be a really good point, really good direction. To be honest, most of the other types of analysis also, if they occur over time, are kind of potentially interesting to contrast to. If you can look at the affect or the kind of team good feeling, you know, what's the sentiment over time? Maybe you could ask, what's the social role of synchronization? Does it make the team bond? Does it have a social role that we feel more connected, more together, and we use happier language if we synchronize? Although I don't know, maybe people synchronize when they're having an argument too. I think those would be the first ones really. I think I'd be curious about kind of any design-related outcomes that we have from the qualitative side, seeing if we can relate them to synchronization in some way. And then maybe also doing something like some kind of sentiment or emotion analysis from the text over time and seeing how that relates, whether synchronization has that kind of social role. Yeah. Okay. Those would be my first ideas, but I'm more interested in other people's ideas.
Very quick.
I think one thing that was recurring also with other people, one thing that was recurring throughout also with other people in the audience was chaos and perturbations, and when something breaks down to build it up again. And that's something that we can probably just compute with your measures, right? Dips, relevant dips of non-synchronization, or even. So I wonder whether something like that, because we all seem to have some, or Jonathan at least, that is needed, right, in this design process. And it also comes back to dynamical systems, and you need a perturbation to get started, and that can be random.
Yeah.
But maybe that will be cool also for people in the audience to think about whether we can operationalize that further, for example.
I agree completely, yeah. I think one of the reasons why it's exciting to have this data in a quantitative way and analyze it using quantitative methods is that you can kind of go into periods of time and maybe start to look at processes that are going on and then see is there a certain process of agreement or consensus, and then disagreement, innovation, brainstorming, and these are all different processes that have profiles or signatures within the quantitative measures. Yeah, absolutely.
Cool. Yeah, perfect. Thank you. Next is AI for Envision.
Come on down, Gerard.
The board is quite far away. Victor, can you help me bring it on that side?
AI? Where is it?
It's a production, movie production.
Where is it?
All right.
So we have like thousands of these whiteboards here
That
standing.
was the whole point.
Yeah.
The whole point. Until you run out of whiteboards.
You've run out of time. There's a synchronicity between amounts of whiteboards.
It's a magic wand. I mean, you remember Gerard's talk.
Right.
I would just let him start, then I have some crazy ideas, but.
I mean, yeah, this is supposed to be brainstorming together, so, but basically, things we'd like to do are starting with the data, just looking for patterns. So you have the annotations that you've already been doing, and we can add more annotations, and then we can start looking for interesting patterns. Like, does this kind of gesture always occur when people are talking about a particular kind of thing, like the future, or does another kind of gesture occur when you're talking about the past, or when you're talking about a physical implementation of some idea, making a physical model out of your design. So there are all these patterns we can start looking for. We can also start with the theory and have certain hypotheses, and then see if we can identify those hypotheses in the data. So as we saw with SPACY and other NLP models, we can look for particular content in the transcripts. We can also look for certain kinds of dialogue elements like disfluencies and so on, and try to connect those to other observations we have. So that's the first step, looking for patterns. The second thing I would think about is now I come to the machine learning perspective. Can we predict things? Can we not just find a pattern, but what if we train a model now to predict the likelihood of something happening? Can we do that? And then can we apply that to other data? And on the other hand, if we have models trained on other data, can we apply it to our kinds of data and see if it still works well enough, or if the setting is quite different, and so whatever worked in another setting does not apply to our data. Our participants are not behaving in the same way. So those are my initial thoughts. There are a bunch of other people with some background in AI, or at least some familiarity. Feel free to chime in.
One of the bugs I got from Kobe and Joachim is deepfakes. And I'm thinking about this challenge we have every time when we have a data set, it's awesome, but we have to either de-identify or blur it out. So I don't mean to put fake heads on like team 10, but could that be something like a deep fake version of the data set? It helps us avoid a lawsuit. Like really ahead that I don't know.
We've been considering hiring actors to do exactly what the people do, so we can show it to people. Meaning, for classes saying, act like this, that kind of thing. This is a slightly different thing, but it's actually pretty useful, right?
Well, first I would use AI techniques just to anonymize the data a bit more, blur out certain things automatically, and maybe at some point the data can be released or
So there's a step before that. That is too crazy. Yeah.
That's the most obvious thing people do. Synthesizing new data. There's always the issue then of how natural it is, how much it matches what we have in the real data. So
It is a question that was also asked and often is asked in our research. How do we de-identify data? And we cannot even share it, right? We want to be open science, but if we have such a tool in anywhere that is openly available, it would be really great for that research community.
That would be fabulous. Right? Because then we could say, by the way, we did the facial recognition already. You don't need to do it.
Yeah.
Right. That kind of thing. Like the facial action units, et cetera, et cetera. We did that. Don't worry about it. We did gaze. Don't worry about it.
The other thing is you can train a model to detect certain phenomena and then see if we can identify similar instances of the same gesture or the same situation or same kind of interaction in publicly available data, such as on TV, or not everything on TV is fake. It could be a talk show discussion round, or sometimes you do have people just interacting to produce something nowadays on YouTube, and that is open data, and that might be another avenue, just exploring if when we identify something interesting in our data, can we find it elsewhere in other data as well?
Yes. By the way, in terms of endpoints, we do have 14 endpoints. It's a single endpoint with 14 instances. For each one, we have endpoints saying this was an incremental change, this was a medium change, this was a big change. So in terms of looking for patterns, saying, well, whatever behavior is here, it's great. Whatever behavior is here, it's incremental. And so we have those because that was part of the study is. So I'm not sure if they're sufficient for machine learning, just saying, well, we have these, each one characterizes this. What are the patterns that add up to those? Or we can cluster them into 3 groups or whatever makes sense, right?
Yeah, the more you have, the better it is. Although as I was saying, small data can also be valuable, but of course, to identify patterns in a statistically significant way, of course, having more annotations helps for larger amounts of time or instances. But we can try it out. And as I was explaining in my talk, now there's gradually a lot of progress where you can train models with very little data just because they learn not just from those few labels you provided, but also all the pre-training on general unsupervised video they've seen and other kinds of patterns.
So it's bringing a whole package of things to it, a whole bunch of stuff.
Right. If there's already some pre-existing notion of, okay, these are the people in the image, and it's understanding already certain kinds of movements, and then you just need a few additional labels for it to start recognizing certain things compared to a blank state where you train a model that has no idea of what people are from scratch.
Right.
That would require way more annotations. So gradually we're moving towards models where we can start with small amounts of data and few examples.
The second half of that, thanks, Jared, is the spacey for Envision as a collab, that style of research in terms of making it accessible. Spacey has a line for explain. And your comment was like any good model or like tool should always have that. Yeah, so in terms of what stood out for you during those sessions, they were very basic, but that was also the point to see how we could copy what really works in other platforms to make this. So I'm just thinking out loud. Spacey for Envision and Google Colab.
Yeah, I mean, Andrea left, but of course his kind of user interface is the ideal situation. Just tap on a few buttons, upload your data, play around with it without having to code a single line of code. But as a researcher, like for researchers, it might be okay to have collab notebooks, and you can share them. You can, without even having any software set up on your own computer, you can using Docker as well as another option. So those kinds of tools enable us to quickly get it started and not have to deal with too much preparation.
Any other thoughts, Max?
What I was thinking is along the line of generative AI. You showed an example of auto completion, like
auto completion, yes.
Start maybe an article and then the machine completes for you. Probably we could just deploy that ideology into videos too, or even gestures, and see what kind of gestures will AI generate for us now. So we have these ones from the videos. Will AI just generate maybe its own home gestures, just generate its own gestures too. See what?
Yeah, we have models now. You give it half a picture, it tries to complete the rest, and also models where you give it a picture and it creates a story around that picture, like using it as an anchor, or even generates the next few frames, like what kind of movement is going to happen next. So that exists. Full video generation is not yet that easy, but probably we'll get there in the next couple of years. It'll be interesting. Let's see. But yeah, Spacey as well plays into what I said before about looking for patterns. So that could use these kinds of NLP techniques and collaborative kind of work. So one of us has some new kind of labels that we either annotate or automatically generate using some software tool, and then we share those. Maybe we cannot share we can share some of the data only among selected group, but we can share annotations that relate to that data more freely if we created those. So that's what often happens in NLP. There's some licensed text and we can't share that, but we can share everything that we created annotating that text. So that can be a way for us to collaborate and work together.
Okay. Awesome, thank you, Jared. I was going to involve Wim and James in a session to brainstorm, but we've done that too much.
Yeah.
I think you're tired of hearing my voice, so maybe enough for tonight. But I'm still going to use the veto power to say that maybe a good idea is to find a journal that is open to like 10, 15 papers on the Envision data set. So maybe you guys need to start a special issue or something, or at least start thinking about it, or it could be good.
Yeah, it's a good idea.
Yeah, definitely.
Barbara, can I just a slightly different kind of frame on this? I want to know, as a group, what can we do that we could get done in a week, or 10 or 15 or 20 hours? I know you've already put many, many hours into this, but just in a reasonable amount. That is, can we pick 2 videos? I have 2 in mind, where we pick 5 minutes of the video, and I could figure out that, or we could figure it out together, and just say, let's run our stuff from different points of view on those 2, so we have something compared to, and it's a manageable chunk, just as a kind of study, rather than saying, let's do the whole Envision set, which would be impressive, but just what's a very small chunk? Is 5 minutes a small enough chunk of 2 things? So we can go, this one was down. Remember, I just said we had measured these people, and saying, this is a good group and it's incremental, and they do certain things that I know they do. And this group 10, which we certainly want to do, let's look at 5 minutes of each of those and just say, let's run our stuff on it and just see what comes out of running that stuff. It's kind of like a teeny little thing. And perhaps we'll get enough for a bunch of publications or a publication, but we'll actually know something, but it's kind of a minimum. And I want a big engagement, but what's the minimum engagement we can get something done and say, in a week, sometime in January or whatever, let's just run this shit.
In our field, we call it the minimal publishable unit.
Right.
Minimal viable product.
But to be honest, I think what would be nice is maybe a qualitative, quantitative, where we have all these different approaches, we apply it, but also can we point back to the data and say, hey, this is indeed what we also see.
Yes.
Some measures you cannot see.
So let's do, is 5 minutes okay?
Yeah.
I mean, just as a proposal?
I don't know. I think we really have to think about that. But
It depends on the variables that we're measuring.
Sure.
Yeah.
But I'm also thinking about all the people online. So how can we get them back together if we want to work together?
Yeah. So that is then where we want to. Oh man, 5 more minutes. I really wanted to know also what worked, what didn't in the event, so that we can do better next time. But I'll just. Lovely people that are still online with us. Thank you for being there. Do you have thoughts to share just quickly I think.
I know they do.
Just 3, Julia, Lena, and Marlene. You could just unmute yourself and just say the word.
Oh, it's synchronization. Who is first? Okay, Julia, sorry.
Okay, I mean, it's a bit frustrating, to be honest, to be online at the moment, because
No, I understand.
Shit, you're breaking up.
so that's the problem right now.
Yes.
My internet is not very good today. But I mean, it's really great, and I'm really looking forward to. I mean, I think I could talk with you like endlessly, like for hours. So a bit like someone else try to express right now.
Yeah, I mean, you could type your thoughts in the chat also. But yeah, good. Marlene, you wanna?
Yeah, I must also say I would have wished to be there in presence. It's always something different, and especially I think for these brainstorming sessions, and really it is a difference being there in person, but still, as it's not possible right now, it was super awesome. Like I really, really enjoyed these 3 days. They were really inspiring, hands-on. And yeah, I definitely took a lot from your input, and it will keep me busy for several days going through the scripts and then trying to understand even deeper and applying the insights into my work. So yeah, thanks a lot from my side.
Thank you again. We would then finalize the recordings tonight and upload everything. So yeah, hope that can help you, motivate you to watch. Lena?
I think the recordings are a really good idea to really go through many of the things again in the script. But I have to say that the virtual version worked quite all right. Oh well, now my headset's turning off. Wow, so maybe it's not working well after all. Can you still hear me?
Yeah,
Sorry. Well, I still took a lot of new ideas and just a very good overview, I think, of many approaches that I now have to reconsider. And I'm also still, I haven't recorded any data yet, so I'm at a point where I'm trying to think about what I have to consider. So I think that was a very good starting point for me. So thank you very much.
Thank you. So I think that is the official closing. It's like a few seconds left and we'll be officially done. I want to say thank you to everyone who dialed in from all over. We want to say thank you. I speak on behalf of all the hosts. Crazy idea. Can only work with crazy.
Started with Boba. Boba did it.
I want to thank Bob.
Thank you. Yeah, there is a notion of affordances in design. Affordance is what gives, it's a potential for action. And I can really say that if it wasn't for the configuration of this host, there were many times where I said, you know, maybe this is not just the right thing to do. And I had those doubts going home every day. I was like, yeah, then COVID hit again, the Omicron, and I was like, okay, they're definitely going to cancel this thing. And then they canceled the Christmas party, and then but it's really good that everyone is here. Thank you, Ola. Thank you, Wim. Thank you, James. Thanks, Jonathan. Thank you. Thanks, Jared. Which are the hosts did I miss? Joaquin. We've been thinking about this type of thing for almost 3 years. Yeah. Yeah, the conditions seem to just make that right. Thank you for joining us. Short notice. What he did in inviting you inspired me to invite Professor Wolfgang, because I was like, okay, I don't think I can talk about that paper as good as that, nuclear physics, and no freaking way. So that worked out. Thanks everyone for joining us and for bearing with us the technical issues first day, and thanks Lola for giving us the support from food and taking photos on the go. Thank you for sponsoring the event, Jonathan. Thanks Gerard for believing in us as students in HPI. I hope that this is evidence for you guys to say that yeah, students are also crazy, and we need faster support in making this kind of event happen. So I learned a lot. I'm still going to watch the videos myself to really master what this guy's inspired. I saw him first on Twitter, and then I went to LinkedIn. He wasn't there, but I found him on LinkedIn. Then I saw their videos and I said, you know, it'd be nice for these guys to talk live again, probably a bit more
Chilled out.
more chill environment. And that was like 2 years ago, and now it's a beautiful thing that we started all together. Envision.
You'll probably repeat it, right?
Yeah.
In Nijmegen when Corona.
Yeah, so that is true. Yeah, so we were asked to keep some modules. We didn't keep anything; it's all out there. But they said, please come to Nijmegen and do something. Stanford also wants us to come next year in March to do something. So
Road trip, Stanford.
so we hope it's that kind of space for us to envision greater things together. Thank you, everyone. I think I'm mostly different tonight, and probably I have a train to catch at 5 a.m. tomorrow morning. So yeah, at least I know that I don't have to make any Zoom links anymore for a while. Thank you, everyone. God bless. See you next time very soon, and look out for the videos because we would stop recording now. Cheers.
Cheers.
Bye.
Yeah.
Bye.
Yeah, of course. You should be here. It's 2 minutes.